Alrighty. So, we're getting ahead of ourselves here. We want to talk about dynamics. Dynamics is basically explaining motion using forces. Right, so we're going to say, well, what forces are acting on an object, and what does that do in terms of making it move? Force is simply a push or a pull on an object. Measure forces in units called newtons. Newton is actually not a simple unit. It's a unit that's made of. There we go. We're gonna get there. All right, here we go. Kilogram. Meter per second per second. So essentially, if you look at this, meters per second squared, that's acceleration. And then we're just adding mass to that. So it's basically mass times acceleration, which we're going to get to as we move along. All right. We're going to draw some force diagrams, and that's how we can use force diagrams to make sure we understand all of the external forces, which means forces outside of the system, and we draw them for systems which are which are rigid bodies. Okay, so even if we add a human, we're assuming it's a non-moving human, at least when we're drawing the forces on it. Right? So we've got this lovely person sitting in a chair, 600 newtons, 40 newton chair, 20 newton physics textbooks. All right? Force diagram of the book. We don't draw the whole thing. This is just our outline. We draw only the book. That is our system. Earth pulls down on it. Earth is obviously outside of it, so that's external. Hands are pushing up. And assuming that it's not moving, the force that the hands are using to push up is exactly equal but opposite to the Earth pulling down. The person doing their wall sit here. 600 newtons pulls them down towards the Earth. Again, Earth is outside of them, so that's external. The book is pushing down with 20 newtons of force, also outside of the person. And finally, the chair pushes up on the person. The chair is outside of the person, also an external force. It is preventing them from smacking themselves down onto the floor. Okay? And so this takes us to a definition here where net external force is just the vector sum of all external forces. So the F net is the sum of force 1 plus force 2 plus whatever other forces are acting on an object. Right? And so I think you can imagine here we could have some kind of a situation where there's forces acting in all kinds of directions, and as soon as you see vector, you're like, oh, we could do components. And we could, and we will get to some later on. In the meantime, though, let's look at a box. Two forces acting on it. Right, we've got F force 1, which is 500 newtons, pushing it towards the right, and force 200 newtons pushing it towards the left. Oh, who's going to win this race? Well, it's definitely going to be force 1. And the net force then is going to be force 1 plus force 2. Again, they're opposite directions. We assume right is positive, left is negative. We've got force 1 is plus 500 newtons, plus negative 100 newtons. And we're left with a 400 Newton net force to the right. Now, we can show the acceleration on this one. We do not draw the net force on our same force diagram. Reason being, right, we don't want to add another force. We don't want to say, oh, look, I've got 400 newtons going this way. Well, suddenly that looks like then now I've got 900 newtons going to the right and only 100 to the left. So we can draw a totally separate picture showing the whole system with only the net force acting on it. All right, let's go. Here we go. Maybe. There we go. Alright, so this is essentially the one that we just looked here. Object experienced two forces, a 500 Newton force to the right and a 100 Newton force to the left. What is the net external force? Most of us could even right away look at this and say, oh, yeah, sort of like a tug of war, I guess, if we're pushing on it, but a push of war or something like that. Anyways, in this case, it's going to be 500 to the right, 100 to the left, 100 to the right. Let's look at how we can get there. We draw a diagram. Okay, we show the external forces. Force 1 is 500 newtons to the right. Force 2 is 100 newtons to the left. And there's our reference system, just to make sure we know what's positive and what positive and negative mean. Here we go. I mean, same solution as before. Okay, what about this one? The net external force is 600 newtons downwards, so we know that now. What's the magnitude of F2? Obviously pushing down fairly strongly because F1 is pushing down with 350, but F3 is pushing back up with 500. So we set it up and say, okay, the net force on this object is F1 plus F2 plus F3. Net force was negative 600. F1 was negative 350. And F2 is the one we want to know. And our F3 was positive 500. Rearranging, solving for F2, we end up with negative 750 newtons, which means the magnitude of F2 is 750 newtons. The negative here is just telling us that it is downwards. And that's really the introduction that we did. Simple and to the point, but this is the kind of stuff that we're going to be using all the time. So a bit of review and looking at it ahead of time is never a bad thing.